This episode is sponsored by Brilliant. Keeping track of time is tricky enough nowadays. It's a whole different story when your clocks and calendars don't have 24 hours or 365 days, let alone run slower. But that's barely the tip of the iceberg of problems with time facing interstellar civilizations. So today we'll be closing out our 5th season for Science and Futurism with Isaac Arthur, and I am your host, the aforementioned Isaac Arthur. As we say goodbye to 2019 and hello to 2020, it seemed appropriate to discuss time, so we'll be looking at its impact on interstellar civilizations today, and we'll open 2020 up next week by contemplating time travel. Of course, time travel itself is a fairly ambiguous term. It assumes time normally runs at a set and uniform pace, and that's nothing like the case. Time runs slower in gravity wells and when you're moving fast, and we happen to live in one such gravity well and need to move very fast to get to any others out in the galaxy in any sort of sane timeline. And sane timeline is probably appropriate, because in many ways it's not the flow of time itself that really matters, but rather the effect all the crazy time issues will have on civilizations and trying to keep those civilizations connected. If you think time zones on Earth are a pain in the modern era of instant communication, that's nothing compared to trying to handle time lag issues on talking to other planets with longer days and years, let alone stars years away in communication time. Now in science fiction this always gets solved by FTL, fast light communications or travel, though in truth that only fixes part of the problem and makes some of it worse. Time zones on Earth are only a problem because we have instant and cheap communication. Prior to that, it didn't matter that it was midnight somewhere when it was noon for you, because you couldn't interact with them in real time. Even in my youth, when long distance phone calls were rather pricey, the time zone thing wasn't as big a deal because you didn't casually interact with other time zones much. With free long distance calls, remote offices, and of course the internet and social media, we now have to deal with time zones all the time. Right now, it wouldn't really matter what the day length or year on some planet around Alpha Centauri was, because we're not talking to a colony there real time, but on a 4-year lag, so it's like sending someone a very delayed letter or email. If you had instant FTL communication, then it matters that they have a really different day and year. Of course, we don't have instant FTL communication, and aren't likely to ever have it. Indeed, we don't have instant communication even here on Earth. It's just so quick that you don't notice the lag much. We are mostly interested in interstellar civilizations today, but it's worth considering how colonizing our own solar system will alter our attitude on time, and interplanetary civilizations will influence how the interstellar ones develop. Let's address the elephant in the room though. Without FTL, it doesn't seem realistic to have a galactic empire in the classic space opera sense, as we looked at in interstellar empires. The galaxy is 100,000 light years across, meaning a message from one side to another takes 100,000 years. We'll try to look at some ways for doing that anyway later on, but for now it's worth remembering that civilization, especially in this context, doesn't mean something centrally run from some capital planet. Colonization of the galaxy doesn't rely on galaxy-wide coordination, any more than colonization of this planet by Stone Age tribes relied on them all getting together to plan things out. So we do want to consider ways that might allow cohesive civilizations like we generally have nowadays, but we don't want to limit ourselves to thinking of them as a prerequisite for interstellar civilization. A developed solar system is an immense place, even compared to a planet, and civilization got on just fine on a single planet prior to radio and telephone being invented. So we've no reason to assume the galaxy would be a chaotic mess just because it was composed of essentially sovereign solar systems who only have limited exchanges with neighbors. But let's talk about the time issues within solar systems, interplanetary civilizations. No naturally occurring solar system will ever have 2 planets with roughly equal year lengths for a starter, as you can't have stable orbits occupied by 2 large bodies, with the exception of double planets. And those will have quite atypical day lengths compared to Earth from tidal locking like our moon has. The only planet with an even vaguely close day length to Earth is Mars, where it's 37 minutes longer and you'd lose about a day a month. That would be awkward for a lot of communication, as teams doing shifts on Earth and Mars, say 3 daily shifts, are going to have things cycle around, so the morning shift in both places can't coordinate more than a few days in a row, as the folks on Mars will get up 37 minutes later each day. That's the easy case too, though in some ways both the Moon and Venus are easier. The Moon has a day and year a month long, and is in near instant communication with Earth anyway, so it's probably just going to use Earth's calendar. Venus and Mercury both have days months long, and essentially useless for human activity-based timekeeping. That will happen on many Earth-like worlds around orange or red dwarf stars too, which is most stars in the galaxy, as even if the day were about the same as Earth's, the year might be just a few months or even mere days long. Back around our Sun, early asteroid mining efforts, which are likely to predate any major colonization of other planets anyway, aren't likely to want to use the rotation or orbit of a given asteroid as a reference point. Asteroids typically rotate several times an Earth day, and they are small places among a horde of other objects with different rotation periods and orbits. Now you might use some major object like Ceres or Vesta in the asteroid belt as a hub for activity and standardize to its local clock, but that would probably be more likely for something more classically planet-focused or concentrated like moons around a gas giant. Also, we have to consider how space colonization is likely to roll out in our solar system, which is to say, we are more likely to build worlds than terraform them via rotating habitats, and those can have day lengths of whatever you want. There's an assumption that Martian colonists will start their own calendar up, and maybe they would, but nobody else really has any motivation to do so. Timekeeping on Earth has to do with human biology adapted to Earth, and biology in general for stuff like growing crops. There's no fields or fertile river deltas out there for us to go farm. We'd be doing everything inside domes or artificially lit and environmentally controlled facilities, and we can regulate those to our taste, presumably Earth standard, at least until living under Martian daylight becomes routine. See Springtime on Mars for more on that. So you'd probably end up with everyone using Earth standard for exchange between places, and probably internally for most places too, though that might alter a bit too. We're coming up on a leap year in 2020, and I could easily imagine those being gotten rid of in some standardized system. You also presumably need to pick a time zone that was the official midnight everyone used. Metric doesn't work well for time units, or rather decimal doesn't. Folks often confuse base 10 with metric, which just happens to use it. Our time measurement for days is still in base 12, two 12-hour periods divided into 60 minutes, or 5 times 12, and 60 seconds, again 5 times 12. There's also the jiffy, a 60th of a second, but we usually switch back to base 10 for that and use hundredths or thousandths or billionths of a second. There's really no natural system that smoothly lets you use the same unit for days and years though, and in an era of computers it's not such a big deal, as they can rapidly convert times and dates for folks between time systems. Earth's got billions of people on it who will never have a motive to change calendars, and by the time you'd have billions of folks living off Earth, they'd be all over the place on different and awkward local times anyway. Indeed, the place most folks are likely to live off Earth early on is in Earth orbit, where the day is a couple hours in low orbit, and in the higher orbits it is longer, but the sun is almost always shining with noontime brightness, since you spend little time in Earth's shadow in high orbits. So, possibly excepting Mars, nobody really has a motive to use local timekeeping for regulating human interactions. You still have them. Folks on Mercury obviously will care when the sun is rising or setting, and doubtless develop local terms for it, in their case something more akin to our month, as it takes about 2 months for a day to pass on Mercury, and they'd have no moon for a local month either. Once you get out far from the sun though, it gets less important what the sun is doing since you really don't see it. You might have observation domes to go out and see the stars and look at distant Sol, but you're doing your living indoors, even if it's some massive habitat with whole forests and parks inside it being artificially lit. Now, while I'd imagine we'd send out interstellar colony efforts within a generation or two of when it becomes practical to try, in terms of success odds and cost, you're not likely to see a big push for that until most of our solar system has been utilized, including all the millions of minor planets inside it. A handful of test colonies around other suns, delayed in growth by centuries of travel time and without easy access to the industrial might of our home system to expedite growth, are unlikely to be the ones setting standards on timekeeping, and the issue is likely to be addressed before they are a major factor in deciding. So too, while some colony on a world under an alien sun might adopt some 26-hour day and 362-day year it had locally. We shouldn't assume that system would develop using that, because they're not likely to start colonizing that system with that planet. As we discussed in the Life in a Space Colony series, a colony ship arriving in a new system with an Earth-like planet for a given value of Earth-like does not just go land there. You do your colonizing backwards, starting in space and building up your industrial might and colonial support before going down and terraforming some planet, a process of centuries at a minimum, and they will have spent decades if not centuries traveling inside a spaceship that is much the same as any habitat or space station they'd build there. Indeed, even once that planet is terraformed, they will likely have had their off-planet population grow so much during that time that they never had most of their population on that planet, so why use its natural calendar? Even if they left Earth planning to focus on terraforming the destination planet, those folks will have lived in an artificial habitat for generations, and the eventual colonists might not find a planet all that attractive compared to just building O'Neill cylinders or similar, a far faster and easier process anyway. Such being the case, why change timekeeping methods? Now if they wanted to, they might slowly change the ship from emulating Earth to Planet X while en route. They are likely to know a lot about the destination, especially how long that planet orbits and rotates and what its gravity is. So if they're going to a planet with 90% of Earth's gravity that rotates every 26.7 hours, while orbiting a dimmer orange dwarf star every 165 of those 26.7 hour days, then they might gradually shift the ship's internal environment to match those, especially since it will help things besides humans adapt, like all the flora and fauna you plan to transport there, which is also another reason to keep your various habitats to Earth normal times. Our ecology is adapted to it, and it's probably easier to mimic it than alter things to different setups. Still, all these various interstellar colonies might alter to a local time setup simply to acknowledge that it might happen eventually, and they really are going to be rather isolated there anyway. They might all keep using the Earth year for official dating for communicating to other systems, but they could also just as easily do that in something metric like megaseconds, about 12 days, or gigaseconds, about 30 years, and just have some official day 0 or second 0 everyone used. If you're curious, we'd be in the 64th gigasecond of the AD calendar, megasecond 746, when the video came out. Of course, the problem is that if they start their clock before they leave Earth, when they arrive it's going to be running slow, which takes us into the other big problem with interstellar civilizations and time, which is relativity and how long such trips take even when moving at relativistic speeds. The closer you get to light speed, the more time slows down, though in truth we're not likely to ever have ships where it slows down to such a significant factor that folks living on them feel like they were fast-forwarding through time. The same applies to general relativity, the slowing of time from being in gravity wells or on an accelerating ship. Time runs a bit slower at your feet than at your head, and a good bit faster on Mars, which has weaker gravity and is also further from the sun's gravity. Time runs fastest in the intergalactic void, particularly the cosmic voids, the big empty spaces relatively devoid of galaxies, and slowest near the center of galaxies, or of course near black holes, which are the center of most big galaxies too. The difference is minimal though, even in extreme cases, but starts mattering when dealing with really long timescales. But it is calculable, so it just means folks have to adjust their clocks or timestamps on interstellar correspondence. The thing is, what date do you actually use? A ship leaving Earth in the year 2020 and arriving at a destination our year 2200, having traveled at 20% of light speed, looking at their own clock, might see that arrival as being in the year 2196, having experienced about a 2% slowdown in time during the voyage. They will also have traveled 36 light years, meaning the signals they're getting from Earth when they arrive don't say 2200 anyway, they say 2164. One might argue, especially if everyone wants to keep some standard timekeeping system based off humanity's homeworld, that maybe they should say that it is now the year 2164 on their arrival, rather than 2200. Of course, to everyone who was awake for that trip, quite possibly all the way from Earth if life extension technology has improved, has still only experienced 176.4 years of travel, not 180. Needless to say, this only gets exacerbated by longer flight times and higher speeds, But it also gets worse if we start contemplating subjective time experienced. If you're born in the year 2000 and got on that ship, you'd be 196 when you arrived. So how old do you say you are, and when do you celebrate your birthday if you do decide your clock is the one that matters? Time was running 2% slower on your ship. So if you were born on January 1st, 2000, your 21st birthday in personal time, which is what you age at and experience, was not on January 21st of 2021. It was on January 7th. But if you check the clock back on Earth, based on signals to your ship, it's going to say it's January 1st on March 14th, because you're 73 light days out from Earth somewhere in our Oort cloud, though your own clock on the ship would say it was March 5th, since you lost about 9 days to Einstein at that point. This is all assuming your ship instantly accelerated too, which it won't have, but it makes the already confusing math a bit easier. And of course that's when you're getting all your mail from home, and it's rather unlikely you've stopped corresponding with friends and family entirely, or watching the news entirely. You're still waiting for your favorite book or show or film to come out, and you have to go by Earth's date for all of that. So you basically have 4 clocks to watch. The atomic clock marking how much time has actually passed on that ship, the radio clock from home telling you what the date was when that signal left Earth, the computer one telling you what the calculated time on Earth is right now, which is a rather debatable concept, and the one telling you what the date would be back on Earth when a message you sent right now actually arrived, if you plan on sending a happy birthday message or gift you bought online to friends or family back home that you wanted to arrive on time. Now if you plan to stay on that ship after it colonized that planet and starts running trips back and forth to Earth, you've got to add in some more clocks telling you what the date on that colony planet is. Folks running some circuit of destinations on interstellar trade routes might go rather nuts trying to track such things, if we didn't have computers they could set reminders on and rely on the computers to inform them. You also definitely need to track shipboard time too, since you're likely to have all sorts of parts and software that have time-sensitive maintenance and replacement requirements. Plus, you'll want an onboard atomic clock to compare to clock signals from various systems to calculate your position and trajectory with high precision, same as we do with GPS location systems. Speaking of computers, there's more than one way subjective time can get messed up besides Einstein. Needless to say, you might lose a lot of personal time by opting for some sort of deep freeze or suspension technology, and that would shut off your biological aging presumably or slow it. See Sleep or Ships for details. You might do this even if you have effective immortality from radical life extension technology, simply because you don't particularly feel like experiencing your decades-long journeys. Now in discussing life extension, I generally dismiss the idea of being bored. I'd need a few lifetimes just to get through all the books on my pending reading list, during which I imagine that list would expand faster than I could read it. But at the same time, there's probably a realistic limit on how much life you can experience in a mostly human form before you fill up your brain. And even with memory enhancing or compression alterations to that brain, I tend to doubt anyone who had actually experienced tens of thousands, let alone millions of years of time, would really qualify as human anymore, simply by the weight of all that time and experience. I would doubt you could maintain your sanity all that time, at least in the sense of human normal behavior. But that brings up mental augmentation, and realistically we'll probably have a lot of that available long before interstellar travel is more than a novelty a very rare few have experienced, indeed likely before anyone has. There's a lot more options to mind augmentation than simply raising your IQ, but when we're talking about superintelligence, we generally classify it in 3 major types. One is quality superintelligence, which is a bit abstract but essentially why one human is smarter than 10 chimpanzees, even though they've got more total brains. Another is networked intelligence, which would basically be making those chimps smarter by wiring their brains together, though more likely by creating a new, distinct 10-chimp single mind, hive minds being one example of networked superintelligence. The third, though, is speed superintelligence, where you haven't actually made someone smarter, just sped up the rate they think at. You might do that by replacing their synapses or neurons with transmitters that were identical except for transmitting at light speed, rather than at roughly the speed of sound or slower as ours do currently. If you made such a switch, you'd be experiencing time around 1 million times faster in terms of your thinking as you currently do. Now one might argue someone who sleeps 8 hours a day and is awake for 16 is experiencing less life every day than someone who sleeps for 7 and is awake for 17. They are awake 1 hour or 6.25% longer each day and experience 23 more days every year, whereas someone who sleeps 9 hours a day and is awake 15 experiences 93.7% as much time. And if we're only counting conscious time, that would match someone traveling at a third of light speed in terms of time dilation. That's obviously a pretty debatable point, as sleep is not the same as shutting someone's brain off, and since it's part of what keeps you healthy, you're not likely to get a longer lifespan, even subjectively, by cutting down on your sleep. Of course, we might be able to rewire people so that they did not need sleep to be healthy and mentally agile. And it would get hard to argue someone who was conscious and not groggy 24 hours a day, 365 days a year, had not experienced 50% more life than folks spending a third of their time asleep, 548 subjective days per year. More so if they're on some spaceship far from Earth's clocks and calendars, or love coffee, the original life extension technology. But with all that mental augmentation in play, they might be able to slow or speed up their personal time quite a lot. Indeed, they might slightly speed their consciousness to exactly countermatch whatever the relativistic time dilation on their ship was. Time running slower from moving at 42% of light speed boosts your subjective time up by 10%. Normally we think of slowing subjective time on spaceships so you don't experience it, but you might go that other way too. Indeed, you might do this on planets with shorter days. Just make up that missing hour in a 23-hour day by accelerating everyone's thinking speed by a few percent. Now on the civilization side of things, all this weird time raises issues. Let's consider something mundane like paying people salaries, or calculating what grade a kid is in, or what your wedding anniversary is, or when your Interstellar Mining Corporation celebrates its 1000th anniversary with a big marketing campaign and discount. With all the complexities we saw for space travelers, it's easy to imagine folks who traveled a lot between stars would just shrug and say, "I'm pretty old." But it's a whole different story if they're contemplating their paycheck, how many years they've got on their pension, what sort of compound interest they're getting on investments, and how much taxes they should be paying. We wouldn't tax someone more or less income tax because they were asleep, more or less. But what about someone in hibernation for a trip? Or not for a trip, just on Earth? And before you say no, let me point out the obvious tax dodge of owning stock in a company for a decade while spending 9 of it on ice, paying only a year's worth of taxes, incurring no expenses besides your freezer bill, and emerging with a decade of earnings. Or alternatively, going on a 5-century voyage on ice for all but a year of it, getting home and being offered a year's salary and paid in 500-year-old values, with nothing for inflation or adjustment for any standard of living increase during that time. You might say you deserve all 500 years of that pay, or maybe the 400 that passed on that ship as it flew around at relativistic speeds, but also keep in mind that someone else might be accelerating their subjective time and demanding 10,000 years of pay as they experience 10,000 years of consciousness. And it might be a fair demand too, if they had to do it to perform their duties. Now we could hand-wave that off as not relevant in some future utopia of immense prosperity, but there's bound to be parallel examples. We're just using modern concepts, and mostly to highlight that there's not any clear and obvious approach. So different places might use different standards. You get on board some ship to serve as a crew member on a 1,000-year voyage to a different pocket of space, and that ship's captain says he pays on ship time, annual salary, but at your destination they expect you to pay income taxes on the voyage if you plan to trade there, for all the local time you spent inside their territory, while your home system is still taxing your assets using their own method, and the Interstellar Trading Guild you're with expects you to pay them their dues based on your ship's clock, but lets you treat time in hibernation at a discount, say 1/10 of the ice time counts, whereas your last guild charged none for hibernation, but expected you to have a tamper-proof chip in your head that measured your subjective time. If you boost your thinking up to 10x normal speed, they charge you 10 times as much. It makes one wonder what overtime at work might mean in such situations too. Now FTL makes this even more confusing since it opens the door on causality violating events, but in the long term, all these time tracking issues get worse. how historians would track the timelines on some 10,000-year-long war operating over 1,000 light-years and 1,000,000 worlds is going to be beyond confusing, especially as battles might be continuing centuries after a ceasefire. Very stable and long-lived societies might be able to form non-FTL empires stretching light centuries, just because they don't really need to write home for directions much as their society isn't changing on a generational basis and differently on each planet. But they also might have figured out some perfect and stable society. There may actually be such a thing in some objective and mathematically provable sense, and regardless, they might feel like they have it or a close approximation. They may also get around light lag coordination issues by having set protocols for how everyone acts in a given scenario, like emergency fleets scramble to a preset coordinate to rendezvous with other fleets from other systems if a given event occurs. Those might get rather complicated since the ideal rendezvous point for given fleet elements would be time-sensitive and dependent on where an enemy or disaster occurred, which they would all observe at different times and have different travel times to react to. Trying to have a Senate or Parliament on an interstellar scale might be beyond tricky too, considering a representative elected and sent to the capital might take several centuries to arrive, presumably begin their term of say a decade, while getting orders from back home from political parties now in control who didn't even exist when they left, and arrive back centuries later to be lynched. Time lag being what it is, you could easily have all sorts of legal necessities too, such as trials in absentia, or hearings to decide what to do with someone's property, who was originally only going to be gone a couple of decades for a quick jaunt to their nearest neighbor system, but due to some unforeseen event or change of heart, got detoured and now you have to figure out what to do with their property and its back taxes, with each system having different rules and those changing every century or so. Some folks have suggested you might just have civilizations freeze themselves most of the time to allow a net experience of time that was slowed down, thus allowing a potentially larger civilization, but I don't see that working outside a special case we'll get to in a moment. Another notion is your interstellar civilization might really just be the trade ships and their proxies or representatives in various systems, as they're the only ones who really need to care about what's going on between star systems much, and would experience that slowed down time anyway, and thus might be a stabilizing or conservative factor. Something along these lines is discussed in Alastair Reynolds' novel House of Suns, one of my favorite novels and one that deals with light-speed limited civilizations trying to deal with millions of years of time passing, or the people who travel between those civilizations and never visiting the same one twice, since they're always gone by the time they return there on their galaxy-spanning voyages. Amusingly, in the long term, some of these problems go away, presumably in part because they've just had a ton of time to figure out what works best. But as we discussed in Civilizations at the End of Time, post-stellar civilizations might camp around black holes, where time runs slower, and take advantage of ultra-core computing to run hyper-efficient but slow computational thinking. For such civilizations, the light lag issue isn't such a big deal, because time is subjectively running at a minuscule fraction of the rate it used to while every galaxy has either merged together or flown over the cosmological event horizon. If you're running at a billionth your normal thinking speed, and so is everyone else, 100,000 light years and 100,000 years of message delay only feels like an hour. And while life moves at a snail's pace, it's still way longer subjectively too. Those civilizations we discussed as existing in post-stellar time could potentially exist for billions of billions of billions of billions of years, so even at that snail's pace of subjective time, they still experience timelines that make the current age of the universe seem like an eye blink. Of course, time and entropy still take their toll eventually, even if you can make such ultra-cold and slow civilizations work, and you might start thinking about wanting to move to new universes if they exist, or, if you figured out time travel, go colonize or invade your own past. And we'll look at how time travel capable civilizations would work next week, if time travel was possible, and if any sort of coherent civilization might be able to exist if it did. As we wrap up the holiday season, let me give you a hand knocking something off your holiday to-do list. Gifts. If you're watching this show, you probably tend to feel like I do that knowledge is one of the best gifts you can give someone. If you know someone who likes to solve puzzles or find out how things work, I've got a brilliant gift for you. Brilliant. Brilliant is an online learning community with over 60 interactive courses, and many quizzes and puzzles, plus daily challenges that help get the brain warmed up for the day. Brilliant makes learning fun and easier, and their online community gives you places to discuss the material or ask questions, and their mobile app's offline feature lets you take courses even when you're not getting a good signal while traveling for the holiday season. This year, get the gift of knowledge for your loved ones by gifting them Brilliant. It's such a fun way to nurture curiosity, build confidence, and develop problem-solving skills crucial to school, job interviews, or their career. Go to brilliant.org/IsaacArthur and grab a gift subscription to help your loved ones finish their day a little smarter. So while we do have a live stream Q&A this Sunday, today wraps up our episodes for the year, and I want to thank everyone for joining me for yet another year of science and futurism. If you'd like to help support more episodes, I'd be very glad to have your support on Patreon, or through any of our other donation methods you can find on our website, isaacarthur.net. And of course we do have more episodes coming, starting 2020 off on January 2nd with a look at time travel. Then the week after that we'll explore alien conspiracies, and the sorts of aliens that might be conspiring and why in Conspiratorial Aliens. Until then, thanks for watching, and we'll see you next year.